Electric dipole and its properties. Physics for everyone welcomes you. And today class, let us learn about electric dipole moment and properties of electric dipole. Let us start the class. Electric dipole. Here in this XY coordinate system, we have placed minus q and plus q at a distance a from origin. Now the dipole moment is from minus q to plus q. It is represented by a letter p vector. Good. This system, what we call it as dipole, let us learn the physical significance, because when two charges equal and opposite separated by a very small distance, they attract each other, they nullify the charges. So it is not practically possible, but in nature this system is available in the form of molecules. So the physical significance: in many molecules the centers of positive and negative charge do not coincide. Such molecules behaves as electric dipole with permanent dipole moment. Good. Example: carbon monoxide, water, ammonia, hydrochloric acid. Good. Let us learn the definition. Two equal and opposite charges separated by a small distance constitute an electric dipole. Good. Though the name is electric dipole, this definition is a vectorical definition and it is applicable for one charge, two charge, three charge from the origin of a coordinate system. Good. Let us learn detail about this electric dipole. When in a system algebraic sum of all the charges is zero, it does not necessarily mean that electric field produced by the system is zero everywhere. This makes the study of electric dipole very important. Here, the total charge is zero. That doesn't mean that there is no electric field around the charges. The electric field exists. Electric dipole moment. Here we have to define the electric dipole moment vectorically. Plus q at a distance of r plus vector and minus q at a distance of r minus vector. Now let us define the dipole moment p vector. The p vector equals qr plus vector minus qr minus vector. This is a vectorical mathematical definition of electric dipole moment for two charges. This can be extended to many charges. R plus vector is the position vector of plus q from origin and r minus vector is the position vector of minus q from origin. The electric dipole moment for a collection of many charges is given by p vector equals sigma I equals 1 to n qi ri vector, where ri vector is the position vector of the charge qi from the origin. For simplicity, let us consider these two charges are available on the x-axis. Good. So p vector equals qa I cap plus minus q a multiplies minus I cap. So the p vector equals 2q a I cap. The electric dipole moment vector lies along the line joining the two charges and is directed from minus q to plus q. Even if the two charges are placed on y-axis or x-axis, the dipole moment will point always from minus q vector to plus q vector. That is why instead of saying I cap, j cap or k cap, we represent it is p cap. Magnitude of electric dipole moment. The magnitude of electric dipole moment is equal to the product of the magnitude of one of the charge and the distance between them. mathematically, modulus of P vector equals 2QA. Let us go with properties of electric dipole. Dipole moment is a quantity which gives information about the strength of the dipole, whether the dipole is strong or weak, that can be determined with the help of electric dipole moment. Second point. Dipole moment is defined as the product of the magnitude of either of the charges and the dipole length. P vector equals 2aq p cap. This P vector is directed from minus q to plus q. Third point. Direction of dipole moment is from the negative charge to the positive charge along the axis. In general, electric dipole moment depends upon two factors. One is the choice of the origin and second, charge configuration. Let us look here. Let us go with the first case. The total charge of the system is not equal to 0. Then let us see what happened. Here you have the first system, two charges each of plus q. So the total charge is not equal to 0. Good. And the origin is selected at the center of the two charges. Let us go for the same system. Now the choice of origin is different. The origin is at the left side, left charge. Right? In these two cases, the choice of origins are different. Let us now check the dipole moment for each case. For the first case, P vector equals plus q a I cap plus q multiplies minus a I cap. So P vector equals 0. The dipole moment for the first system, for the first charge configuration with the origin at the center of the two dipole is 0. Let us go for the second case. P vector equals plus q 2a I vector plus q into 0, because one of the charge, that left charge, is at the origin. Now the dipole moment P vector equals 2aq I cap. Good. For the first case, the dipole moment is 0. For the second case, the dipole moment is 2aq I cap. It's because of the choice of the origin. But for one special case, the dipole moment is independent of the choice of origin. If the total charge is 0, then electric dipole moment will be the same irrespective of the choice of the origin. And it is always directed from minus q to plus q. Let us check now. The total charge of the system equals 0. Here you have two charges equal and opposite, so the total charge is 0. The origin is at the center of the dipole. Here the same system, but now the origin is at one of the charge, that is on the negative charge. Let us check the dipole moment for these two cases separately. For the first case, P vector equals plus q a I cap plus minus q multiplies minus a I cap. So totally we get P vector equals 2a q I cap. Second system, P vector equals plus q multiplies 2a I cap plus q into 0. So P vector equals 2a q I cap. In these two cases, the dipole moment is same and the direction is directed from minus q to plus q. So let me read again. In general case, the electric dipole moment depends on the first, the choice of the origin, and second, the charge configuration. Good. SI unit of the dipole moment is Coulomb meter. The CGS unit of dipole moment is d by. 1 d by equals 3.3 into 10 power minus 30 Coulomb meter. Dimension of dipole moment is L power 1, T power 1 and A power 1. A region surrounding a stationary electric dipole has electric field only. Examples: H2O, CH3, CHCl3, NH3, HCl and CO. Look at here, you have different atoms of the molecule, mostly constitute a permanent dipole with permanent dipole moment. Thank you, children.